So dear student, in this session we will learn how to experimentally determine critical constant Tc, Pc and Vc. Cagniard de la Tours developed an apparatus for the experimental determination of critical temperature and critical pressure. Please note that in this experiment we can't determine critical volume, that is Vc, but Cagniard de la could determine Tc and Pc, only these two constants, using this apparatus. So this apparatus consists of simple components. This consists of a glass bulb A containing only the liquid and its vapor, whose Tc and Pc to be determined. Suppose you want to determine Tc and Pc for carbon dioxide, then you should fill carbon dioxide vapor phase and its liquid phase. Okay, carbon dioxide liquid and vapor only, nothing else should be present in bulb A. And this is connected to this manometer. This part B shows the pressure, that is manometer, and this is the heating jacket which surrounds the bulb A, and this is connected to thermometer. So these are the components of Cagniard de la Tours apparatus. So what you have to do, initially you heat the bulb, gently heat the bulb by passing hot water. Note down the temperature at which this meniscus disappears. So in the beginning you go on heating by passing hot water or any liquid which increases the temperature in the jacket, need not to be hot water. You have to note down the temperature at which this meniscus existing between vapor phase and liquid phase disappears, that is T1. Once it disappeared, increase the temperature to again bit higher extent, then you go on decreasing. Decrease the temperature slowly and note down the temperature T2 at which this meniscus reappears. Okay. Now to find the Tc, that is critical temperature, you have to take the average of T1 and T2. Okay. So Tc is equal to T1 plus T2 by 2. Now to find critical pressure, you need to record the pressure P1 and P2 at the corresponding temperature T1 and T2 using this manometer. Okay. So to find Pc, you take the average of P1 and P2, that is P1 plus P2 by 2. That will give you critical pressure. As I already told, the critical volume cannot be determined using this apparatus. No direct method. So you have to make an indirect method for the determination of Pc, that is critical volume, using this Cailliot and Mathias method. It follows this Mathias rule, which states that mean of densities of any substance in the state of liquid and saturated vapor at the same t is a linear function of t. Okay, if you see it here, mean of densities of any substance, here this is the mean densities which is plotted against the temperature, is a linear function of temperature. Okay, you get a straight line when you plot the mean densities of the substance which is in the vapor and the liquid state. Okay, so it's very simple. I'll explain. You have to take the mean of densities of the liquid and the vapor of one particular substance. You plot it against the temperature, you will get a straight line. Using this method, you can find out Pc. How will you do it? You take any substance. First you plot the graph of densities of the liquid and the vapor phase. So densities of vapor increases along the curve AC. You know, densities of vapor phase, if you increase the temperature, it will increase. Okay, and so density of vapor will increase and density of liquid will decrease with the increase of temperature. You must have realized, suppose there is a liquid, you increase the temperature, it will slowly get converted to vapor phase. So vapor phase is having lower density compared to the liquid phase. So the density of liquid has to decrease. Okay, see, the density of liquid is decreasing, density of liquid vapor phase is increasing. So now you extrapolate this. Okay, extrapolate this, that will meet at the point C, and that is critical temperature. Okay, where density of liquid and the vapor phase coexist. So what you have to do next, you take the mean densities of this. Suppose at this temperature density of vapor is A and that substance temperature is, density is B. Now you take the mean, that will be D. Okay, again you take the mean of this and this, it will be this point. Take the mean of this and this, it will be this point. Take the mean of A dash and B dash, that will be D dash. This is a linear function, so it will give a straight line. So plot it and extend it, it will meet at this point C. Okay, so at this critical temperature. So now this mean of these densities is nothing but dc, that is critical density. Okay, so once you have determined the critical density of the substance, so how will you find out vc, that is critical volume? By using the simple relation vc equal to m divided by dc, where m is the molecular weight. We know density is equal to mass per volume. That's why mass is equal to volume into density, or volume is equal to mass divided by density. So whatever dc you get here, okay, so that you have to make m divided by dc to get critical volume of that substance. Hope you have understood. In summary, we have seen the Cagniard-De la Tour's apparatus to determine Tc and Pc of a substance, and we also saw how to determine critical volume by Cailletet and Mathias method. You remember this Mathias rule. These are the references. Thank you for watching.